What's up, chemistry guys and girls? This video is question number 14 out of your solution notes. It's on molarity. So we did one concentration unit on percent mass. Now we're going to do what's called molarity. This is the most common concentration unit. Almost everything I make is made in a certain molarity. So I'll use the same solutions I had before, but these are the molarities of them. So this solution is a 1 molar solution. And this solution is a 0.1 molar solution. So what that means is this. This is a 1 molar solution of copper sulfate. So that means that there is 1 mole of copper sulfate per liter of solution. Well, I don't actually have a liter here. I've got about half a liter. So I don't have a full mole, but the concentration is still that. If this same concentration was a liter, there would be a mole of the dissolved stuff in here. This one is only 0.1 molar, so it's 10 times less concentrated than this one. So it's 10 times less concentrated. So there's only, this one actually is a liter. It means there's only 0.1 moles of copper sulfate for this whole liter of solution. So again, it's a concentration unit. Not chemicals you want to taste, obviously. So in these ones you can look at and see which one's more concentrated. But sometimes you need to know the actual exact concentration of them. And again, if I wanted to make this more concentrated, I would add more solute to it. If I want to make it less concentrated, I would add more water to it. So here's letters B and C on your notes. Just calculating molarity. So you get molarity again by dividing your moles of your solute, the stuff being dissolved, which is usually a powder for most chemicals we're using, per liter of solution. That's not per liter of water, but per liter of solution. So first one there says you have a 100.5 milliliter intravenous solution, or IV solution, and it contains 5.1 grams of glucose, also the molarity. So first thing I need to know is how many moles are there of solute. So I know I have 5.1 grams of glucose. So I'm going to convert that into moles. And for glucose, it's 180 grams per mole, so I have 0.0283. How many moles we have of glucose. And that is dissolved in enough solution to make 100.5 milliliters, which needs to be in liters. So there are 1,000 milliliters in 1 liter. So that's going to give us 0.1005 liters. So if I want to get the molarity, I want to know how concentrated 1 liter would be. How many moles would there be in 1 liter? Well, there's that many moles and that many liters, so we're going to divide them. Moles divided by liters, so 0.0283 moles per 0.1005 liters. Again, molarity is always moles over liters. And it's signified by a big N. Usually it's italicized. So this concentration would be what's called 0.282 molar, which means there's 0.282 moles of glucose dissolved in a liter of solution. Letter C there, same thing, trying to figure out the molarity of a solution. Obviously, the higher the molarity, the more concentrated. You can't, and there's usually a limit, because at a certain point you can't dissolve anymore. Like when you're making Kool-Aid, you get to a certain point where you can't dissolve any more sugar. So letter C there, again, this is question number 14. Sorry, screen's going off. Letter C there, I'll start this direction a little bit, is saying that you have 1.6 liters of solution and it has 1.55 grams of KBr in it. So take our grams of KBr. We need to know how many grams of KBr are in a mole. For KBr, it's 119 grams. So we have 0.013 moles of potassium bromide. And that is in 1.6 liters. So our molarity would be 0.013 moles per 1.6 liters of solution. Pretty low concentration. So divide those two, and we get a molarity of 0.0081. You can just put a big M for molar. Again, that means that there is 0.0081 moles of the potassium bromide, which is a powder, dissolved in a liter of solution, probably water. Question 15 will be on a different video.